We're going to be looking at operations with polynomials, and what we want you to be able to do, your learning target, is that you can add, subtract, or multiply polynomials when we're done today. All right, so this first one on your note sheet says, Shelly has narrowed her choice for which college to attend. She's most interested in Southwest Minnesota State University, where the current year's tuition is $3,872. Shelly assumes that tuition will increase at a rate of 6% per year. Express the tuition after X years as a polynomial. Okay, so on one problem like this, we know what her starting amount is. That would be right here, $3,872. It's increasing at a rate of 6% each year. Okay, so that means if you're starting at 100% and we're increasing by 6% every year, every year's tuition after the first year is going to be 106% of what it was the year before. So when we enter this into our equation, anytime you got a percentage, we're going to need to change it to a decimal. So 106% as a decimal would be, we got to move the decimal point over 2 times. It's right here, 1, 2. That means this is going to be 1.06. So if we wanted to find out what the next year's tuition was, we would take 3,872 and times it by 1.06, and whatever that amount is, that's the tuition for the next year. Okay, if we were going to do it another year, we'd again multiply by 1.06. So we're going to repeatedly multiply 1.06 times itself. This would then be each year, or X would be the number of years. So this would be a polynomial then that would solve it out. We're going to be looking at polynomials and how you can find out different things about them. All right, so a degree of the polynomial. Whenever they're asking you for the degree, that's the value of the largest exponent, or it's the sum of the exponents of any monomial term in the polynomial. Let's look at some examples. So this first one, there is only one term here. The exponent is 5, so we would say that this is degree 5, since that's the biggest exponent. Okay, in our second one, again, we're just looking at exponents here. We have 3, 2, and this one doesn't have any, which means this is like 8 to the 0 power. So our biggest number out of 3, 2, and 0 would be 3. So we would say that this one is degree 3. All right, for C, we have 2 terms here. We got this one and this one. The second one has degree 1. Our first one has 2 exponents. So if you have multiple exponents, what you do is you find the sum of those. So if we add these up here, 7 plus 4, the degree of this one is 11, since 11 is bigger than 1. So that would be degree 11. Okay, on these next ones, what you're going to do is try to identify what the degree of the polynomial is. So we'll do one, and then I'm going to have you guys try one. On the first one here, okay, again, we're looking at exponents. We got 2 terms. This one is 4. Here we have multiple terms, so we got to find the sum. Looks like 8. The bigger of these two, between 8 and 4, is 8. So this would be degree 8. Okay. Why don't you pause the video, try number 2 out, see what you find for the degree of that one. All right, let's check out what you got here. A couple of these variables don't have exponents, so anytime they don't show it, it's 1. So this one is going to be 5 plus 1, or degree 6 for the first term. This one's 4 plus 3, or 7 for the degree of the second one. This is 1 plus 1, or 2 for the degree of the third term. Looks like 7's the biggest. You should have answered with 7 if you did it correctly. All right, so degree, we're going to keep looking at degree throughout this unit. That's going to tell us some different stuff later when we start looking at the graphs. Okay, some operations we're going to be doing today: addition, subtraction, multiplication. If you are adding polynomials, you want to combine like terms. If you are subtracting polynomials, you want to add the opposite, then combine like terms. And finally, multiplication, you want to distribute. Remember, distribute's multiplying. Then, again, combine any like terms. All right, so let's try some examples out here. The first one looks like we have a subtraction problem. So we're going to subtract these two polynomials. When we had subtraction, it said add the opposite and then combine like terms. So right here we have this negative sign. We're subtracting every term here. Okay, so if we're subtracting all these, it's almost like you have to distribute that negative sign to each thing. Okay, so when we do that, what you're going to end up with then is the 3x squared, the minus 2x, and the plus 3. Nothing changes about these, but then we have minus x squared. Okay, now we got to distribute to this one, the negative sign. So negative times 4x, that's going to be minus 4x. And then we got minus negative 2. For subtracting a negative 2, that's basically like adding. So it's going to end up being plus 2. Okay, another way you can do this rather than distributing would be to add the opposite. So some people like doing it like this, where you change this to a plus and then you go through and change the sign on all these, and it ends up being the same thing, that this one's going to be negative, this is going to be negative, and this is positive. Okay, now we got to go through and add like terms together. 3x squared minus 1x squared is going to be 2x squared. These are like terms. Negative 2 minus 4 is going to be negative 6x. And then finally 3 plus 2 is 5. And that would be the answer of the subtraction. Okay, let's try another one here. Number 4. We want to add this. If we're adding, there's nothing really to do except combining like terms. So we got 5x squared minus 3x squared is 2x squared. Negative 4 plus 1 is going to be negative 3x. And then 1 minus 3 is going to be negative 2. So adding super easy, just combine like terms. All right, let's try another one here. We got another, looks like subtraction one here for number 5. Okay, so subtraction, we just did one of these a little bit ago. Add the opposite. So this is going to turn into a plus. We want to then go through and change the sign on all these. Now if we add the like ones together like we did on the last problem, we should get the answer. Negative 1x squared plus another negative 1x squared is going to be negative 2x squared. Negative 3x plus negative 2x is going to be negative 5x. And then 4 plus negative 5 is going to be negative 1. So on subtraction ones, make sure you subtract everything in the second term. All right, one last adding one here. Let's check this one out, number 6. This one wants us to add. Okay, so we want to look, is there any like terms to 3x squared? No, there is no other x squared term. So if that's the case, that's just going to go right to our answer. All right, let's look for the next biggest degree or power of x. It looks like this one. Is there any like terms to that one? Nope, so just minus x. Finally, we have these two constant terms. These we can add together. Negative 6 plus 1 is going to be negative 5. So if there's no like terms, don't do anything with it, just move it to your answer. All right, let's go to the back. On the back, we're going to do some multiplying now. So on number 7, we have this 2x term being multiplied to the parentheses here where there's 3 terms. So we need to, like we said before, distribute and then see if we can combine any like terms. So if we distribute here, we're multiplying 2 times 7. That's going to give us 14. Now we got to combine the x's here. Now from yesterday, we know if we take x times x squared, that's like a power of 1 there. When we're multiplying, we add exponents. So this is going to end up being 4x cubed here. Okay, then multiply again. 2 times negative 3, that's going to be negative 6. We got x times x, which is going to be x squared. So that's x squared. And then finally, if we multiply the last one, 10x. None of these are like terms because they all have a different degree of x. So that's our solution. All right. Let's get another one here. This one's another one where we're distributing. Why don't you pause the video, try this one out on your own, see what you get. All right, let's see how you did. If you multiply these first ones, two negatives, that's going to be positive 6a cubed. Again, if you multiply here, two negatives is going to be positive 22a squared. And if you multiply the last one, minus 40a. None of them are like terms. They all have a different degree. There's the solution. All right, let's get number 9. Another multiplying one. This one they want us to multiply out here. Now this one's a little bit harder because now we got 3 terms in the first parentheses, 2 terms in the next one. We got to make sure we distribute everything here. So let's start with this first n squared. We're going to have to multiply that to both things over here. So if we multiply that out, we got n cubed plus 4n squared. Okay, now we got to move to the next term. This one's going to need to get distributed. So multiply that one to both. So if we take 6n times n, that's going to be 6n squared. 6n times 4, that's going to be plus 24n. Finally, we got to take this negative 2 now and distribute. So if we distribute that, that's going to be minus 2n. And negative 2 times 4 is negative 8. Now we got to see, is there any like terms? Yeah, these two are like terms. And these two would be like terms. So add the like terms together to get your final answer. It would be plus 10n squared plus 22n minus 8. None of these other ones are like terms now because they're all different degrees of n. That would be our final answer. All right. Again, why don't you pause the video out here, try out number 10, and see how you do on number 10 here. All right, let's see how you did. If you distribute these through, multiply this one to both, you're going to get 6x cubed minus 2x squared. Next one to both, this one's negative, so negative 12x squared. Two negatives are going to be plus 4x. And then finally the last one, plus 15x minus 5. Combine the like ones here, and the final answer you should have gotten is this. So that would be the product of those two. All right. Some things where this might show up in biology. One thing that you talk about is like how you get your genes and how you get your traits from your parents. Here it says, suppose R and W represent 2 genes that a plant can inherit from its parents. The terms of the expansion of R plus W squared represent the possible pairings of the genes in the offspring. Write R plus W squared as a polynomial. Okay, so we want to write this out, R plus W squared. One easy mistake that people make on this, and this is you're likely to see this on the ACT, just because of the fact that a lot of people make mistakes on this, is that people will write the answer as R squared plus W squared. No, that's not the answer. You can't just square both things when there's multiple terms. There's 2 terms here. If it's 1 term, you can just square everything. But when there's 2 things, this is something different. Think about what it means when you square something. If you're squaring something, that means you're multiplying it times itself. Like 10 squared, I know you guys know it's 100, but the reason it's 100 is because 10 squared means 10 times 10. Okay, and that equals 100. So same thing here. If we have R plus W squared, this means R plus W times another R plus W. So if we want to figure out the polynomial from this, we're going to have to distribute. We got to multiply this out. If you want to use that FOIL acronym that some of you have learned, you can do that. So if we multiply the first things, we get R squared. If we multiply the last things, we get R times W. If we multiply the inside things, we get WR. And if we multiply the last things, we get W times W is W squared. All right, now we got to check, is there any like terms? Now, at first glance, it doesn't appear that anything's the same, but these are actually 2 like terms right here. If you're multiplying something, it doesn't really matter the order you multiply them. For example, 5 times 3 equals 15. If we switch the 2 numbers around, it still equals 15. Multiplying doesn't matter what order you put things. So if we switch just one of these around, say we switch the second one around here to say RW. Now you can see, yes, that is a like term to this one. So the polynomial would be R squared. If we add these up, 2 RWs plus W squared. That would be the polynomial. So that would be the different possible gene pairings. If this was like dominant and recessive traits, like that one of these would be the 2 recessive, 2 dominant, or there's 2 chances where you could get one of each. All right, last problem. It says the volume of a rectangular prism, you guys talked about rectangular prisms in geometry, looks something like this, is given by the product of its length, width, and height. Samantha has a rectangular prism that has a length of b squared units, a width of a, and a height of ab plus c. What's the volume of Samantha's rectangular prism? Okay, so if we're going to find the volume, we want to take length times width times height, multiply all these together. They told us what all these are, so we want to multiply a times b squared times ab plus c. This last one we need to put in parentheses because there's 2 terms there. So anything with more than 1 term, you got to make sure you put in parentheses. All right, so express this in simplified form. Looks like what we need to do now is distribute to get our answer because we got 2 terms in the parentheses there. So our volume would be, okay, if we're multiplying this a times a, that's going to be a squared. B squared times another b, that's going to be b cubed, or b to the 3rd power. All right, now we got to multiply to the other one. There's not really any like terms, so it'd just be a b squared c. That would be the volume of this. And now if you knew what a, b, and c were, we could plug them in and find the answer. All right, you're going to try some of these out on your own now on the practice.